All right, I want to start with a group activity. All right, you ready? Let's all take a deep breath in and out. Pretty easy, right? Well, if it wasn't, then you're one of the 454 million people who struggle to catch their breath every single day. These people suffer from a variety of different diseases, cystic fibrosis, COPD, asthma, or even COVID. But what they all share in common is the area of their body that's most affected, their lungs. I study a very specific but often overlooked part of the lungs, which is the mucus layer that lines them. And this mucus layer has a very important job. It traps all the dirt, dust, and germs that we breathe in every single day so we can later cough and expel them so they don't cause us any problems. But unfortunately, in almost every single airway disease, this mucus layer is disturbed in some manner, whether it becomes so thick and sticky that it sticks in our lungs, or so thin and watery that it pools in the basement. Either way, it's not doing its job. And these patients suffer from an increase in lung infections, inflammation, lung damage, and sometimes death. In fact, 4 million people die every single year as a result of lung disease. My research aims to understand how do different lung diseases change the mucus properties so that doctors can develop better therapies to treat it. One of the ways that I do this is I take cells from healthy patients and from patients with different lung diseases, and we grow them in our lab like a lung mimic. We then measure the mucus properties on top of this lung mimic, such as how thick and sticky it is. We then can treat these lung mimics just like a patient, where we give them the drugs used to treat the different diseases, and we measure the improvements in the mucus properties to see how effective the therapies are, or if they aren't, where they can be improved. My preliminary data suggests that ivacaftor, a drug used to treat cystic fibrosis, works by making their thick, sticky mucus slightly more watery or more hydrated so it's easier for them to breathe. What's really cool about using this particular method is that we can try to use ivacaftor in ways it hasn't been used for yet in people, such as trying it on different airway diseases, because imagine the potential impact of millions of people could benefit from a little hydration boost to their own mucus too. So with that, I hope we can all breathe just a bit easier, knowing that doctors and engineers are collaborating together to improve your mucus properties, because the comfort of a deep breath is something everyone on this planet deserves.